The purpose of the bleed air system is to collect and distribute bleed air to the systems that use bleed air. The bleed air system gets bleed air from three sources: the engines, the APU, and an external air cart. The components and the systems that use bleed air are the engine starter, the air conditioning packs and pressurization system, wing and engine thermal anti-icing, pressurization for the potable water tank, and pressurization for the hydraulic reservoirs. The bleed air system has two sides, left and right. The isolation valve separates the left side and the right side of the bleed air system. The engine and APU bleed air valves control air that goes to the bleed air system. The air conditioning pack valves control air that goes to the air conditioning packs from the bleed air system. The controls and indicators for the bleed air system are on the forward overhead panel. The isolation valve switch controls the isolation valve. The engine and APU bleed air switches control the engine and APU bleed air valves. The air conditioning pack switches control the air conditioning pack valves. The bleed air duct pressure indicator shows the bleed air pressures for the left and right ducts. The APU is a primary source of bleed air for air conditioning and engine starts during ground operations. The APU bleed valve controls the APU bleed air that goes to the left side of the bleed air system. Open the APU bleed air valve and look at the indications. When the APU is on and the bleed air valve is open, bleed air from the APU goes to the bleed air system and the duct pressure increases. Bleed air is now available for air conditioning and engine starting. Now select the left air conditioning pack valve to auto and look at the indications. Before you select the right pack to auto, select the isolation valve to open. Now, select the right pack to auto. The APU now supplies bleed air to the bleed air system and the air conditioning packs. During flight or on the ground, the engines can supply the bleed air system with bleed air. The engine's compressors supply bleed air to the bleed air system. The engine bleed air valve controls the bleed air that enters the bleed air system. If the switch for the engine bleed is open, the engine bleed air pressure opens the valve. The engine bleed air switches are normally kept in the on position. When the engines are running, the bleed air valves open and engine bleed air enters the bleed air system. When the engines supply bleed air, select the air conditioning packs to auto. When the left engine valve switch is on and the APU bleed valve is open, the dual bleed light illuminates. The dual bleed light shows that it is possible to back pressure the APU with engine bleed air. The dual bleed light illuminates if the bleed valve switch for the right engine is on, while the isolation valve and APU bleed valves are open. In this example, the dual bleed light shows that the right engine bleed air can also back pressure the APU. While the dual bleed light is illuminated, avoid engine power above idle. Now that the engines supply bleed air, the APU bleed air is not necessary. Close the APU bleed air valve and look at the indications. The isolation valve separates the left and the right sides of the bleed air system. The isolation valve switch has three positions: closed, auto, and open. When the switch is in the open position, the valve is always open and the left and right sides of the bleed air system are connected. Now close the isolation valve. When the switch is in the closed position, the isolation valve is always closed and the left and right sides of the bleed air system are separated or isolated. Now select Auto on the isolation valve switch. The normal position of the isolation valve switch is auto. When the switch is auto, the isolation valve can be open or closed. When the pack switches are auto or high and the engine bleed air switches are on, the isolation valve is closed. But if a pack switch or engine bleed switch is selected to off, the isolation valve opens. Move the number 2 engine switch to off and look at the isolation valve. With the isolation valve switch in auto, the isolation valve opens when the number 2 engine switch is moved to off. Now move any bleed air switches, the pack valve switches, or the isolation valve switch and look at the position of the isolation valve and other indications. Press the green arrow when you are finished. While parked, you may use an external air cart to supply an alternate source of air. The external air cart connects to the right side of the airplane and the bleed air system. Before using the external air cart, make sure the battery switch is on. The battery powers the protective circuits of the bleed air system. Turn on the battery now. With the temperature controls set as desired, select the recirculation fan to auto. Continue. Now, open the isolation valve. Because the external air cart supplies the air for the bleed air system, the APU bleed is not necessary. Turn off the APU bleed. When an external air cart supplies air, you can select the packs to auto or high. Turn both packs to auto now. Continue. Review the steps necessary to connect an external air cart to the bleed air system. Press the green arrow to continue. When the external air cart supplies air, the bleed air duct pressure should be between 20 psi and 25 psi. If the bleed air duct pressure is less than 20 psi when an external air cart supplies air, use the APU if it is available. To start, select the isolation valve to auto. Now, turn on the APU bleed. The APU supplies air to the left pack, and the external air cart supplies air to the right pack. Review all the steps to connect an external air cart to the bleed air system. Press the green arrow to continue. After parking at the terminal, you change the source of bleed air for the bleed air system from the engines to the APU. Before you open the APU bleed valve, open the isolation valve. Now, open the APU bleed valve. Now, shut down the engines by touching the start levers on the aisle stand. The APU now supplies bleed air for the packs. To shut down the air conditioning system, turn the packs off. To fully shut down the bleed air system, turn off the APU. The APU bleed air valve closes. The bleed air system is now shut. Let's look at the steps necessary to perform a no-engine bleed takeoff and landing. If additional thrust for takeoff is necessary, for a go-around, perform a no-engine bleed landing. The steps for a no-engine bleed landing are the same as a no-engine bleed takeoff, but you do the steps during descent when below 10,000 feet. Just before takeoff, or when below 10,000 feet, you set the switches for no engine bleed with the letter C pattern on the air conditioning bleed air controls panel. To start, make sure the right pack is in auto. Now close the isolation valve. Make sure the left air conditioning pack is in auto. Turn off the number 1 engine bleed. Turn on the lap. This sequence of steps has turned off the bleeds from each engine, while the flow of bleed air continued to at least one pack. The bleed air system is now set for a no-engine bleed takeoff or landing. Review the steps, then press the green arrow to continue. After you complete a no-engine bleed takeoff, do the steps in the opposite order to put the bleed air system in the normal configuration for flight. Turn on the number 2 engine bleed. Turn off the APU bleed. Now, before you turn on the number 1 engine bleed, make sure that the cabin rate of climb is stable. This makes sure the APU bleed valve is fully closed before you open the engine bleed valve. Turn on the number 1 engine bleed. Make sure the left pack is in auto. Turn the isolation valve switch to auto. Then, make sure the right pack switch is in auto. The sequence of steps sets the bleed air system for normal flight, while the flow of bleed air to at least one pack continued. Review the steps, then press the green arrow to continue. The overheat test switch tests the detector circuits of the wing body overheat system. To do the wing body overheat test, press the overheat test switch for a minimum of 5 seconds. Press the overheat test switch now. The wing body overheat lights, the master caution lights, and the air conditioning system annunciator light illuminate after you hold the switch for 5 seconds. When you release the switch, the lights extinguish if the system is correct. Let's discuss some of the non-normal indications on the air conditioning bleed air controls panel. When the temperature of the bleed air is more than limits, or when the pressure of the engine bleed air is more than limits, the master caution and air conditioning annunciator lights illuminate, and the bleed trip-off light illuminates. When the bleed trip-off light illuminates, the related engine bleed air valve closes. After the bleed air is cool, press the trip reset switch. When you press the trip reset switch, the bleed trip-off light extinguishes and the related bleed valve opens. If the temperature and pressure are now less than limits, the system operates normally. If the temperature or pressure are still greater than limits, the bleed trip-off light illuminates again and the related bleed air valve closes. If the bleed trip-off light remains illuminated and wing anti-ice is necessary for the flight, turn off the pack on the affected side. In this example, turn off the right pack. When you turn off the pack, the isolation valve opens and the bleed air system supplies air to the right side for wing anti-ice. There are 2 wing body overheat lights on the air conditioning bleed air controls panel. The lights show that there is a duct leak in the bleed air system. The wing body overheat detection system has sensors that detect bleed air duct leaks from the bleed air system. The system monitors ducts in the wing and engine strut areas, the air conditioning bays, and the bleed duct from the APU. When the left wing body overheat light illuminates, the system has found a leak in the left side of the bleed air system. When the right wing body overheat light illuminates, the system has detected a leak in the right side.